Shivaji. Yeah, so I'll be discussing visual introduction to structural dynamics with Python because there are so many complicated equations in structural dynamics. Those who have done their graduations, and some of you might have done post-graduation in structural engineering. So we have a subject called as earthquake engineering, or sometimes the subject is also called as structural dynamics. But it is not just of academic significance. As we go through the content of this presentation, you will understand that this forms a basic building block for our understanding to become a sound structural engineer who has very good understanding of structural dynamics. It is absolutely necessary because nowadays we are building really tall, we are having complicated geometries, and all these are challenging situations for structural engineers, for which you need to go with dynamic analysis. And dynamic analysis, because the code is absolutely making it mandatory to go with dynamic analysis. And nowadays we have softwares also which help us in doing this complicated dynamic analysis, but understanding is necessary. Without understanding, if you just go and use any software, which is maybe STAT, maybe ETABS, if you use, you may not have that insights which are necessary for making a decision. So that's why you need to have fundamental understanding of structural dynamics, not just mathematical, but visual understanding, because we are not going to crunch the numbers as we have calculators, we have computer programs, but theoretical understanding is absolutely necessary. Okay, so I'll go ahead. Since today I was preparing this presentation, I think on Telangana had an earthquake of magnitude 5 on 4th December. If I'm correct, it was very early in the morning, 7:26 a.m., 5 magnitude 5. So, and today also in the morning, if you can see, this was an earthquake reported. So if you could just understand that across the world, the earthquakes are really making damaging impact on lives of the people. Because you must have heard this famous saying that building earthquakes don't kill people, buildings do, right? So this website, National Center for Seismology, gives us insights where the earthquake is happening, and you will come to know that okay, most of the Indian part is having some or the other seismic activity for which our buildings are to be designed. And the code has been revised in 2016. Draft version is there. 20 again 1893 is going to get revised. 16700 is revised recently, 2023. So things are moving ahead, and dynamic analysis is becoming the most important thing. No longer equivalent static is accepted as an analysis tool. We have to go with dynamic analysis, which is response spectrum, then modal analysis, all these things. If you are familiar with some softwares, you'll get what I'm saying. Okay, let's go ahead. So what are the codal recommendations? Why should we study structural dynamics? So as I told, this all are the screenshots taken from IS 1893. So code is clearly telling us linear dynamic analysis shall be performed. See, there is no, now most of us are in zone 3. Very few people are in zone 2. But even if you are in zone 2, the code is only restricting equivalent static analysis only up to 15 meters, and that too for regular structures. And nowadays, we are not having a very perfect regular geometry. There are people insisting on having double height floors, double height living rooms. So regular structures are no longer built. Okay, so linear dynamic analysis at least is absolutely mandatory. Then they are telling us, okay, time history or response spectrum you must have to adopt. So we are not reached yet to go ahead with the time history analysis. That is one of the challenging method yet. But if you want to go for, let's say, performance-based design or evaluation of your building's performance, time history analysis is must. Now, why I have included this is, see, time history analysis is nothing but n number of single degree of freedom system analyzed for a significant ground motion which is recorded earlier or filtered, or there are some synthetic earthquakes also for which we test our buildings. But now we are, at least in our current practice of India, we are just focusing on response spectrum method, but slowly it is going to change. The code is also making it mandatory. Now, if you really want to design buildings with response spectrum method, first thing you need to know is what is the modal analysis, and then how many different modes are to be considered. How do we change the modal behavior by changing the stiffness of some certain elements? Because there are restrictions given in the code. See, they are clearly telling if you have how many numbers should I number of modes should I consider. They are clearly telling the to sum total of modal masses must be at least 90% of the total seismic mass. Now that means number of modes you need to consider. Now one more thing, just recently I'm doing one project wherein we are in seismic zone 4. And in seismic zone 4, the requirement is even strict. Now, what the code is telling that you must have first three lateral torsional modes that have to contribute at least 65%. And this is requirement. The most important or crucial part is the fundamental two principal plan directions must differ by each other. The time period must differ by 10%. So I'll just show you. This is what I was working on. So when I was doing the revisions of design, the fourth revision gave me time period of 4.43, the difference between the x direction and z direction. Okay, this was done in stat, so that is why you see tx and tz. But then I went ahead with the revision. See, earlier 4 revisions, there were some other challenges also. See, from revision 4 to revision 5, when I came, I got 12% difference in the time period. Now, this requires understanding, fundamental understanding of dynamics. So without this, you cannot design a building. So this is really crucial understanding. With this, let's go ahead. This is, I don't know if you have seen the Perform 3D software. This is the example from the Perform 3D software's, what you can say, verification problems. So here, if I play this, you understand that for a series of, rather for this is for time history analysis. If I do for given earthquake, how the building is responding. And based on that, you set out your performance objective and you check whether the performance objectives are met or not, or what is the building damage state at that particular time history. So now we have to go ahead to this level. Now to reach to this level, there has to be a significant understanding of starting with the single degree of freedom system, then you go to multi-degree of freedom system. Both of this is linear. Then you go to non-linear, and then you go for non-linear time history analysis. Okay, so this requires all building blocks clearly understood. Then only we'll be able to reach to this stage where we can say we are moving towards performance-based assessment design. And that has to be the future, because we see a lot of people are investing money in construction, but they need to have a very clear-cut understanding of what revenues they are getting and how is the building's performance over the design life of the project. Okay, so if people are investing crores of rupees, they need to know what is happening to their building. Okay, so one of the requirement is this also. That's why you must be proficient in the structural dynamics fundamentals. Okay, one more thing I have. This is what I call as the heartbeat of the structure. Okay, so we see first 3 modes. Of course, this is a study model. So if you see, when I do any project, or when you will be doing any project, there is a strict guideline from the code that first mode and second mode must be translational. Okay, now here you see the first mode is translation in X, the second mode is translation in Y, the third mode is torsion. Okay, so you have to ensure this. Now, believe me, achieving this is a huge task. Okay, in complicated projects, you have to do n number of revisions till you achieve this. Okay, and of course there are practical limitations, but code does not accept. Okay, you have to make first mode and second mode as translation mode of vibration. Now, how will you achieve this? There is a modal mass participation. All these things are there, which you need to clearly understand. Of course, that is part of multi-degree of freedom system. So if I go ahead, okay, this is the model which I was talking about. This is a G+4 building, which is in seismic zone 4. Now, if you see, This is the translation mode. In Stat Pro, if you see, it is the Z direction. And in the second mode, it is translating along X direction. And third mode will be twisting. Okay. So this is a real project. The previous slide that you saw was a study model. Okay. So this is what we have to achieve in real life so that our structures are code compliant and safe also. Okay. So these all buildings that you see, they are mathematical models in 3 dimensions. If I wish to simplify that problem, I can get it to a 2-dimensional state. Now this is a 2D view of a building frame. As we say, this is a reinforced concrete moment resisting frame, which is having multi-degree of freedom. Now what we do is we follow the lump mass analysis. Okay, what I do, everything that is there at this floor level, I lump the mass and call it at M1. Everything that is at the story 2, I lump the mass and that will be my second mass, M2. Similarly, third and similarly fourth, right? Fourth, I am deliberately showing a different color because there is roof line, which we generally don't consider in our seismic mass. Now, every story had certain stiffness, K1, K2, K3, K4. Now, that is what we need. Understanding of vibrations, understanding of natural frequency, understanding of natural circular frequency. All these are related to fundamentally 2 things. What is the mass distribution? What is the stiffness distribution? And how will you control this so that structural behavior under vibration is as per our requirement, okay, or as per the codal requirement. So naturally, you can't directly jump into doing this multi-degree of freedom system straight away because it is already complicated. So this is generally how you must have started your driving process. First, when you was maybe a kid, you started using cycle. Then you go to, let's say, you go in your teens, you may have your bike. And when you have, let's say, mid-20s, mid-30s, you may have your car. Okay. Now, if you're driven, if you're able to ride the cycle, it is quite easy to ride the bike. And if you are comfortable or you're a good driver with a bike, you can drive your four-wheeler very comfortably. Now, what is the effort here? It is, in this case, in bicycle, rather simple bicycle, everything is manual. Okay, you have to do paddling to bring it to the speed. Yeah, is background noise. Okay. So this is how you started. And I'm not saying that you can't directly start riding a bike or you can't directly start driving a car, but that is difficult. Okay. That is little challenging. So the fundamental understanding of single degree of freedom system, if you do, then only you can replicate the same to the multi-degree of freedom system. Okay. That's why it is absolutely essential for us to start from the fundamentals. There is no escape from this. Unless and until we understand single degree of freedom system, we are unable to understand and digest the multi-degree of freedom system. And our real life problems are multi-degree of freedom systems. So that is why the focus has to be in learning in totality what is the response of single degree of freedom system. Maybe damped, undamped, forced, or free, all these kinds of, there are 4 conditions only, 4, or you can say 6, damped, undamped, forced, free. Okay. So all this, if I understand, this is the building block for going all the way to time history analysis. Okay. So that's why it is extremely important for all of us to understand single degree of freedom system. Okay. Now, I don't know if you have studied mathematics, you have enjoyed it or not, I don't know. Okay, but for most of us, mathematics is not a joyful experience. We just see equations, 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 and we don't understand the physical meaning of the same. For example, if I say sine wave, I won't be able to visualize what is a sine wave. Okay, so the formula for sine wave is simply like a sine 2 pi ft. Okay, so a is the amplitude, f is the frequency, right? Here we are going with cyclic frequency. Okay, and then g is the time. Now, if I need to understand what is 1 hertz sine wave, what is 4 hertz sine wave, I'm unable to understand what is the difference between the two. Okay, because I don't know if you have seen in IS code also 33 hertz is the cutoff frequency if you have seen. Okay, so how do I differentiate between two sine waves of different frequencies? And same goes with earthquake. As we will see, earthquakes have different frequencies. A single earthquake has n number of frequencies. Okay, so frequency domain analysis is another popular way of analyzing the structures, which is in the frequency domain. Okay, so we have Fourier transform and fast Fourier transform and all this. Okay, but we'll be focusing in the time domain, not in the frequency domain. So if I have something which will give me the power to visualize the equations, okay, then only I may relate to those equations. These equations are meaningless to me unless and until I can myself plot these equations, okay, and see the difference. So if I do this, I have a programming language which I can use, which is easy to access, which is free to use, and I can simply plug in the numbers and I can plot and I see the difference. So now I really understand if I am having sine wave of 1 hertz, it completes 1 cycles in 1 second. If I have sine wave of 4 hertz, it is completing 1, 2, 3, and 4 cycles of oscillation in 1 second. So it is very clear to me. Okay, this is a 4 hertz sine wave. This is a 1 hertz sine wave. So similarly, I have cosine waves also similarly plotted. So understanding an equation requires to plot those equations yourself. Okay, if you could achieve that by any means, you use Excel, you use C, you use C++, you use MATLAB, you use Python, you use R, whatever language of your choice. Okay, that only will give you deeper insights into the equations that you see. Okay, so why I particularly chose sine wave? Because when we study forced vibrations, we study with harmonic forces, or which are nothing but sine forces. So what is the general formula to use? It is P0 sine 2 pi ft, where P0 is the magnitude or amplitude of the force, and sine 2 pi ft, F is the forcing frequency. Okay, so I don't know if you have dealt with machine foundations before. You have a machine which is vibrating at certain frequency. So that load you have to consider, and you have to avoid resonance. Okay, that is one more particular phenomena that you must all be familiar with, because we use this day to day in our structural design practice. We always must have to avoid resonance. Okay, so if you are doing machine foundations, it's extremely crucial. Unless and until you know frequencies and analysis for frequencies, you cannot design a foundation, or you can design the slab for that matter, or any structural element for that matter. Okay, so all this is possible if I have some power of visualizing the equation. Now, how do I do that? How do I visualize the equations? For that, okay, one more equation that I will show you. This is the damped single degree of freedom system subjected to harmonic force. Okay, now what is the response? And believe me, we are going to derive these equations or the solutions. Okay, this is the U of t, that is the displacement response for damped single degree of freedom system to harmonic force. Now, if I'm seeing at this equation, okay, nothing gives me any understanding of what this response actually means. Okay, this is simply ABCD to me unless and until I have a power to visualize this equation. Now, how do I do that? If I plot this, there are two responses that I see. One is the transient component, because if you see here, there is damped frequency associated. So it is going to die down. And this is the forcing frequency. So omega is the forcing frequency, which will continue. And this vibration will keep on vibrating until it is your force stops. Okay, so you have a steady state response. Okay, so I have to visualize, okay, what is happening. So this is how I will visualize. Okay, so the transient response that you see is in this color. Okay, the response is getting died down over in each cycle. Okay, and then that depends on what is the damping in the system. And steady state response is this one, which is there vibrating with the forcing frequency. Now, summation of these two is my total response. Okay, that is how the system is going to respond. Okay, so the red color one that you see is the total response of a structural single degree of freedom system subjected to harmonic force. Okay, so now this gives me certain insights. Okay, what is going to happen? How much is the transient component? How much is the steady state component? And who is influencing the response? Is it the transient component influencing the response, or is it the steady state governing the response? Because if you see, as you go ahead, you move ahead, the total response is almost matching with the steady state response. Because if you see here, the transient response is a little more, but if you go ahead, it is getting died down. It is reducing in each cycle because it is having damping inherent. Okay. So all this is possible only if I have power to visualize the equation. And that is the key aspect which we miss during our college days, or even when we are practicing. We are at the mercy of the softwares which are there with us. And many of the time, these softwares don't give you the plots that you need. Okay, you have to do the processing yourself. Okay, so that is one drawback. But nowadays, most of the softwares give application programming interface. So there are APIs, you can write your scripts and interact with the software. Okay, so Python is there for almost all the softwares that you need. Okay, you can write your customized scripts, and you can take whatever information you want and present whatever information you want so that you make an informed decision. Okay, so now which softwares? Okay, not which softwares, which programming languages you can have. So MATLAB is, rather I would say MATLAB was the go-to programming language for scientific computing. Even if you go to any IITs, they are using MATLAB left and right. They always extensively use MATLAB. But the problem with MATLAB is, okay, we'll discuss that further, but there are options available. C++ is there, C# is there, Python is of course there. Okay, so these are few, what you can say, popularly used programming languages for at least scientific computing. Now, I'm particularly focusing on Python for certain reasons. Okay. MATLAB is also there, very fascinating, very good software, very good programming language to say. But the problem with MATLAB is it is owned by someone, okay, and they charge you very heavy licensing fees, and only academic institutions can, what you can say, bear those expenses, or you have a commercial practice. But in structural engineering, we don't need MATLAB as such, apart from the dynamic analysis. So we won't be purchasing that access to MATLAB, which is very costly. So in that case, MATLAB is not the option for me. Okay, as a common structural engineer, I won't be using MATLAB much, because first question is always the licensing. Okay, it's a very expensive software. It's very heavy software also. Requires almost 20 GB to set up. Right, that is huge. So that those are the disadvantages, but there is advantage with MATLAB also, because it is a proprietary software. It has a documentation, well-written documentation. Syntaxes don't change abruptly, because Python is an open source language. Many times the development versions are changing. Now the current version we'll see when we go. Okay, so many times the previous version file will not work in the new version, or there will be changes in the syntax for which you don't even know, because we are not regularly following with the Python development. We are just interested in doing our script and utilizing the script for our use. So that is major drawback that Python has. But now the things are settling down. Python is also stable, quite stable. And it is compatible. Like from version 2 to version 3, it was a big change, right? So that is the problem with in most of the open source languages that you have. But Python still has a good community from where you can derive support, and any problem you have, simply you can Google, and you can get the answers too, right? So MATLAB has very good documentation. MATLAB has their own tutorials. MATLAB has a good website on which you can learn MATLAB. All these things are in favor of MATLAB, but the problem is the licensing, and it is not accessible, right? So even I'm not going to use MATLAB core MATLAB because I don't have a license for the same. There is a cheaper alternative, not cheaper, I would say a free alternative available, which is called as Octave. I don't know if you have heard about this program. This is a Octave software which is similar to MATLAB. Of course, we had a Scilab version also. I don't know if you have heard about that. Scilab is also one particular scientific alternative to MATLAB, which was free or which is free, I believe. But I have stopped using MATLAB. So, but I still believe if you have good, if you are working in an institute where MATLAB is accessible, so you should use MATLAB. But I would say the Python version is much more intuitive. Okay, there are no what you can say. You can think and you can simply do this programming in Python. So the online version of Octave is also there, which we'll use very soon. Okay, because I want to demonstrate few things with you. And there is a Python version. Okay, Python has so many alternatives from which you can choose. Today I'll be demonstrating you with Colab. That is the Google's platform wherein you don't need to install anything. You simply have to have your Google account and you can start programming on the go. Okay, you don't need to install anything. You don't need to invest on a computer for that matter. You can do it on your mobile or tablet, whatever you have. Python has numerous advantages. Most important, it is free to use, right? I can create my customized design design, not spreadsheets, I would say, design scripts I will make. Like I have so many custom made sheets for design of slabs, design of tension member, design of compression member. I just have to take the forces from the software and I can design and I can produce the reports also, right? So that is a good way of using Python for our purposes. So not only you learn structural dynamics along the way, you learn Python as a language, and you can utilize that for whatever purposes you feel that you can use it for. That is limitless, but you can use Python to optimize your workflow, be more productive, and do the stuff in very less time compared to what you are doing manually. Like Excel, you have okay. Excel has also is a lifesaver many times. Excel is always there for us. But you need to go ahead and go beyond Excel, okay? Because in many of the offices, you have Excel as the go-to tool for design. You have spreadsheets made and you use those spreadsheets. But you must have used Excel and you must have realized there are so many things that you can't customize. So language advantage is always you can do a lot of customization. Whatever you want, you can do. Okay. With that said, let's go ahead and okay, we'll go to demonstration. Okay. So I will simply stop this share and then I'll share my this one. Just a second. Yeah. I hope you can see my browser. Yeah. Okay. So now what I'll do, I will simply do some demonstration on how do I use Python or maybe for MATLAB for that matter. Okay. So I'll just move this. Okay. Okay. Just a second. So I'll go to Octave Online. You can download the, okay, I'll just show you what is the software I'm talking. Octave, you can download this GNU Octave, which is almost like a MATLAB. It's not MATLAB, it is almost like a MATLAB, which you can download and install in your system. This also is almost 1 GB setup, I believe. That you can mirror for your you can almost same functionalities of MATLAB you can have. but I will be using Octave online. Okay, so I'll simply go here and I'll demonstrate few things. Okay. Okay. So let's let's go to the software. Okay, this is then I have rearranged this. Yours may not look like this if you are using for the first time. Okay, I have logged in also. If I can see, yeah, I have logged in. So this is how your screen may not look first time, but you log in. It's free. No problem. Simply rearrange these windows. Okay, here also I'll change. Okay. Okay. Right. So now what I'll do, it's like a calculator also. You can see, I'll say 4 plus 5. I don't know if you're able to see. This is the prompt that I'm entering into. Okay. I hope you are able to see. Okay. Just a second. Yeah. So if I do 4 plus 5, let's see what is happening. Okay. He is telling me the answer is 9. And answer is the variable that it took. Okay. Now we see, we are not computer engineers that we accept, but there are certain things that we need to understand. What is a float? Okay. Uh, what is a number? Okay. What is the precision of computer? Okay. All these things. What is a float? What is other things that? What is a string? All these things we need to understand for our convenience only. Okay. We are not going to be a computer engineer or the terms that they use. We are not interested in that. We sorry, we are structural engineers or civil engineers. We are more interested in getting the job done. Okay, so variables are okay. Somebody is notating in my screen. Okay, fine. So now I'll say A is equal to, let's say I give A as 5. So it is storing A as 5. And if I give B is equal to, let's say 6. Okay. And I'll say C is equal to, okay, B. Okay. What is it? A plus B. Okay. Now, if I redefine A and B, my C will be updated automatically. Like I can tell you, let's say W is equal to 4 kilonewton per meter, and my span is, let's say, 6 meters. So my bending moment comes out to be, okay, so it is W into L square, right, by 8, right? So if I'm having a simply supported beam, let's see. Okay. So it is telling me a bending moment of 18 kilonewton meter. Why I'm demonstrating this? Because we can use this as a variable, and we can change this and run this thousands of times. Every time in fraction of second, it is going to give me what is my bending moment. Subsequently, you can put in the formula for reinforcement also. Or if you're doing structural steel design, we need to do classification of structures, where it is, whether it is a compact, semi-compact, or plastic section. Okay, so you just have to do it through what is the thickness of flange, what is the thickness of web, all these things. Okay, for that matter. Okay, one more thing that we regularly do is the matrix analysis. Okay, so I can input matrix in MATLAB. This is how you will work in MATLAB. Okay, that's why I'm showing you. If you are interested in working in MATLAB, you can start matrix by a square bracket. Okay, and I'll give this as 1 space 2. This is my first row, and I'll say 2 space 3. This is my second row. So if I give this as input, this is my matrix 1, 2, 2, 3. Okay, and I'll give M2 as second matrix. Let's say 3, 4, semicolon 5, 6. Okay, so this is my matrix. Okay, now what I can do, I can take a product of the two. Is the product possible? You know, okay, it is M by N, M by N. So the dimensions are matching. So we can have a product. Let's say PR product is equal to M1 times M2. Okay, variable name need to be entered correctly, and I'll get their product. Okay, so you can very easily see the product of matrix 1 into matrix 2, right? So, and in structural analysis, one more thing that we do is we take inverse of matrix. That is very important operation, mathematical operation that we do. And without this, our stiffness matrix method cannot exist. So we'll try doing an inverse of this. Let's say M3 is equal to inverse of, let's do M2. Okay. So very quickly it will demonstrate, right? This is how you, okay, I don't know if you are familiar, you want to check this answer, you can check it in Excel also. Okay, we can do inversion of matrix in Excel as well. Okay, this is one more important operation involved in structural engineering. Okay, so this is MATLAB version of this. Maybe I should go for plot also. Let's see. Let's plot a sine wave. Okay, let's get t is equal to the time vector. I'll get lean space. Okay, lean space starting with 0, going all the way to 1. Let's take 1,000. Let's take 100 points. Okay, let's take 1,000 points. Computer has to do. Let's check. Oh, right. Okay. I forgot to give colon so that it populated all 1,000 values on my screen. Okay. Anyway, I can clear that. I'll simply say clear my screen. Okay. So there is a variable stored if you are able to see. Okay. This is a t vector, my time vector stored. Now I want to find value of sine at each time t. Okay. So what I'll do is I'll say x is equal to, or I should say y is equal to sine of t. Okay, sine of, and I'll give colon this time. Okay, so it has stored, see, within fraction of second, it could calculate corresponding value of sine for each value of t. Okay, now I can see the sine wave. Okay, I am going from 0 to 1. So I purposefully took that, starting with 0 second, going all the way to 1 second. Okay, so now let's say plot. Okay, I want to have t vector on x-axis and y on the y-axis. Okay, let's see what happens. Okay. Yeah, I made a mistake. What is that? Okay, this should be the sine wave is, maybe let's correct it quickly. Y is equal to sine 2 pi f. I'll take 1. Okay, that is the formula, isn't it? Right. So this is 2 pi f t. Okay, now it should do. Let's see. Oh, now he has updated, and I'll change. I'll copy this command again, and I'll plot the sine wave. Okay, let's. Yeah, I got the sine wave. Can you see? Yeah, I hope you are able to see a sine wave starting with 0, going all the way, amplitude reaches to 1, and in 1 second it completes one cycle of oscillation. Now if we see, just writing sine of theta is not going to mean anything to me unless I see, okay, what is happening. Okay, I can change the amplitude also of this. See, but I hope you get the point what I'm trying to say. Okay, so unless and until we visualize, okay, we are unable to uh, understand what is happening behind the scenes. So maybe if I go with, let's say I want to have a 4 hertz sine wave. Okay, so I'll change this. Let's say y4 is equal to, now what I want to do is 2 pi ft, right? So I want 4 hertz sine wave. So 4 into 2 becomes 8, right? So if I do this and I give semicolon and I'll give plot, I want p on my x-axis and y4 on the y-axis. Okay, now you can see it is a 4 hertz sine wave. How do I know? 1, 2, 3, and 4 cycles of oscillation it has completed. Okay, so I can compare very easily. This is 1 hertz sine wave, this is 4 hertz sine wave, right? That is what you should be able to do in understanding structural dynamics as well. Okay, that is the whole point of using the programming language. But of course, this is MATLAB. Let's go to Python very quickly. All right, so I'll go to Google Colab. Okay, one more thing. I'm not going to use Colab in the codes. We are going to do scripting using Visual Studio Code, okay, which is a very good code editor, especially for beginners because it has autocomplete. It gives you information. There are alternatives also. You can use Anaconda, you can use Jupyter Notebook, you can use Pyder, or you can use PyCharm. All these are alternatives. I'll make sure that you install all the three. What we can say, it is the interpreter. Okay, Python. Ideally, we say. Okay, so wherein we write the script. I'll show while I close this webinar. I'll show what I mean. But just for the sake of demonstration, because since none of you have Python installed in your system, uh, this is the on-the-go version, but we are not going to use that in our course. We'll be using, we are going to make a script and execute in VS Code, okay, Visual Studio Code, very interactive, or you can do that in PyCharm also, whatever you prefer. I'll install it in three different IDLEs. One is VS Code, other one will be PyCharm, and the third version is Anaconda distribution will install. There is Jupyter Notebook, which is popularly used by academicians, Jupyter Notebook, and there is Spider. Spider is also very good integrated development environment. Because if you, I don't know if you used or if you heard about OpenSees, okay? I don't know, maybe while I close this demonstration, I'll show you. There is a Python version of OpenSees. You can do a lot of things with OpenSeesPy. So I don't know. If you're doing research, the most updated or most advanced software that you can use for free is OpenSees. But it is written in TCL. So it is a little challenging for us to digest. But there is a Python version of the same, which is developed recently. So OpenSeesPy is a fascinating library which you can use even for commercial projects if you are having understanding of Python. So you don't need to pay heavy charges of licensing to, let's say, STAD or ETABS or something of that sort. Okay, but of course, drawing and all these things are easy to develop through STAD or Bentley distribution and ETABS also. But there is a way. AutoCAD also charges very heavily, right? There is a free CAD version. There is a Python version of CAD, okay, which is free. You can use it commercially, right? All these things are there. Okay. When you log in into Google Colab, it will ask you to log in, okay? And then there is an option of creating a new notebook. So I'll create a new notebook in Drive, okay? So it is getting created. Just a second. Okay, this is how it looks. Okay, let's give this name to, okay, just a second. Okay. What is the advantage of using this Google Colab? You don't need to install anything. The libraries which are necessary are already installed. Maybe I'll zoom in a bit. Let's see. Yeah. Fine. So I'll just say intro as the file name. Right. So let's start. Okay. This is really good. Let me see if I can increase the font size. Font size I'll increase. Okay. So, okay. So now I want, let's say, print. Okay. I want to print to the screen. So I'll say print in single quotes. Welcome to Structural Dynamics course. Okay. And if I run this cell, okay, there is an option to run. Okay. If I run, it's taking time. Just wait, because this is the first time we are initializing this. It will take a bit of time. Next time onwards, it won't. Okay. Right. It's connecting. Yeah. Yeah. Right. So you see a message has popped up on our screen. So when we are doing structural dynamics analysis, or when we want to say in STAD also you must be seeing, or on ETABS also you see the analysis process, starting this, completed this, all this analysis log that you see are the messages printed through command through the program or the script to the user interface. Okay, so you also can do the same, right? Most of you, if you are using STAD, you always use editor. It is very friendly for, you know, to edit a file in STAD if you have editor. Of course, ETAB also has editor, but people use STAD editor very often than ETAB's text file. Okay, so there are two things in this. Okay, there are two things. One is you can add text also. So if I say hash mathematical operations, okay. So if I press shift enter, it runs, or you can run from here also. Let me click on shift enter, runs this. Okay. So you can create, that's why this is called as interactive Python notebook, IPYNB. Okay, it is a notebook. So I can give titles. Maybe if I can give you one more subheading, so I'll go with 2 hash addition. Let's okay, and I press shift enter. This and this you can make out the difference. Okay, so now I'll just simply add. I'll say a is equal to 4. Okay, and I'll say b is equal to 5. Right. This is what I have. I'll simply say C is equal to A plus B, right? And I can print what is the value of C. Print C, right? Yeah, it is giving me the answer. Okay, so in Python, there is, I don't know if you have learned C, C++, it is nightmare for me when I studied C, but I really don't like that language. Python is very, very user friendly because I don't need to declare whether it is a float, whether it is an integer, whether it is a string. Python is smart enough to understand this. That headache is gone. Okay, that is really important for you. You can focus more on programming than on what is the data type. Okay, so that is extremely beneficial. That's what see, when we start learning something, the initial roadblock that you hit is the errors that you get, and you will get discouraged because of that. But in Python, errors are, unless you make a blunder, there is it works okay, right? So that way, Python is not discouraging you to uh, it is not discouraging you to learn. Okay, that's why you enjoy working with Python. Let's see, I added. Now I can simply change this. Okay, 5, and I can change this to 9. Okay, and I can rerun this and I'll get a different out. Okay, similarly, I can use this and see in Python see always whenever you write programs, it is extremely important to write comments. Okay, so I'll say a hash. The comment is, let's say, calculating bending moment. Okay, bending moment. Now I can give whatever variables I want. So I'll say load. Okay, load is equal. Now I'll say this is, let's say, 5, and in comment I'll say kilonewton per meter. Okay, this is my load. Now I'll say span. Okay, span. Span is equal to, let's say, let's give 10 for that matter. 10 will be too much. Let's go with 6. Okay, so this is spanning meters. Okay, now how will I get my bending moment? So I'll simply say bending moment is equal to load, or I can use W. That is very easy. Let's change this to W. W into, I have L. Now in Python, square is written like this, and I have to put bracket because otherwise it won't work. Right? WL square by, okay, I have to give this as L, right? Now divided by 8. And I'll say print, and I'll say that the bending moment is, and I'll give comma, and I'll say B. And then again I'll give kilonewton meter. Okay, and let's do this. Okay, so he's telling me the bending moment is 22.5 kilonewton meter. I can change the spans loading here. I'll change this to 15 and rerun. Within fraction of second, I got my answer, right? So this is way faster than your Excel, right? You just have to write one program and you'll do whatever you want, because see, in Excel you are not going to get this beautiful output that you got here, right? So using Python is a very good tool to have in your uh, in your skill set, because it can do wonders for you. Okay, right. So this is very basic calculation. So let's go and do the same plotting of sine wave. Okay, let's do. Okay, here I'll initialize. Okay, we need a library to initialize. So import NumPy is a library. Don't worry, we'll install all these libraries. I'll tell you how to install. Okay. Otherwise, if you don't follow a proper guideline, you won't be able to utilize their full potential. Okay. So I'm importing a library. I'll import one more. Um, Okay. Mm, yeah, I hope I have not made any spelling mistake. Let's see. Yeah, no. So let's initialize the t vector like we did. T is equal to empty dot lin space. Let's get linearly spaced. So that is how Python is better. Lin space, I just want linearly spaced variables, or the values from, let's say, 0 to 1, and I want to have, let's say, 100, or let's do 1,000 points in between. Okay, so I can give a comment. This is time vector, time vector. Right, I want my sine, so sine wave, I'll go with this, y is equal to np dot sine. Okay, what I wanted, it is 2. Okay, one more thing I need pi. So for that, I need math. Okay, so import math. Okay, so I need 2 pi. So pi comes from math library. So it is math.pi, 2 pi f. I'm taking 1 here, and t, right? So this is my sine wave. Okay, now I want to plot this. So I'll say plt dot plot. Okay, what I want to have, I want to have t on my x-axis, right? And y on the y-axis. Okay, let's do this. Okay, I got a sine wave. Okay, maybe I'll zoom out a bit. Yeah. Yeah, I hope you are able to see, right? One more thing I can do is can simply say plt dot show, so that it doesn't give this line here. Okay, now this is perfect, right? Now I can do customizations to this, but let me do one more thing. Let me say this label is equal to 1 hertz. 1 hertz. Yeah. And I will repeat this. Okay. And I'll get a 4 hertz sine wave also. Okay. So I'll get y4. Okay. A lot of copy pasting we can do. Now this is 2 pi f, right? So f I'm taking 4, let's say. I want a 4 hertz sine wave. So I'll say 4 hertz sine wave. This is 1 hertz sine wave. Okay. So now I want to plot the same, rather this on the same plot. Okay. I'll give label as 4 hertz. Okay, I want to plot this in the same graph. So I'll simply say plt dot plot. Okay. And one more thing. Okay, let's do this later. Okay. What happened? Label LA, label. Oh, oh, mm, not here. Okay, this is the mathematical calculation. How can it do? Okay, just a second. Yeah, this should do. right? Let's do two commas, fine. Yeah, I got this idea, right? And see, Python is smart enough to give the colors. Of course, we can also give colors if you want. Let's say color is equal to red. I want this in red color, and I want this in, let's say, color equal to, let's say, I want this to be blue. Okay, and I want to change the axis because if you see, it is going little away from 1 and 1. I want it to start plt.x limit. I want it to start at 0 and end at 1. Okay. And for y, I'm not worried. I also want to have grid. So I'll say plt.grid. And I want to have a title also. So I'll say plt.title. And I want this to be my first sine wave. Okay. Whatever you want to write, you can simply write. Okay. And it will be displayed. Right. Okay. So I'll run this and you'll see the change. What happened? COL, color spelling. What is the color? Okay, I know what is the shortcut for this. Maybe I different just have forgotten the spelling, but it will still work. Which is not closed. Okay, this is not closed. Fine. See, that is how it is good. Okay, what is this? Uh, okay. Again, I made a mistake. This is not here. This has to be here. This has to be here. Just a second. This should work. No. Okay. Yeah, finally. See, I was putting it here, whereas I should have put it in the plot command. Anyway, this is how I can differentiate. I can have whatever I wish, I can plot. Okay, this is a very nice looking plot, which you cannot get through Excel also, right? So this is what I want for all of us to understand, not just a simple sine wave, which is it's a cakewalk if you understand, but much more complex equations, like I showed you, the response of single degree of freedom system for damped systems, over damped, critically damped, under damped, all this. Okay, let's do a matrix operation very quickly. Uh, or should we, okay, just let me just show you because it is what we did in the same. You just have to change the syntax and just do the matrix operation. Beyond this, I want you to learn or have a look at OpenSeesPy. Okay. And also I'll go to Python. Okay. Let's go to the official website, python.org. Where is it? This is the official website of Python. And this is the OpenSeesPy that I'm talking about. So you can do 2D analysis, you can do nonlinear analysis, all these things you can do. Uh, so OpenSeesPy is really fascinating tool to have, but you need to have a basic understanding of Python, which we can build through this, and then you can use OpenSeesPy also. Okay, the current version that we are having, okay, is which version? Which version is there? Download. Let's go to, yeah, this is 3.13 version. Okay, now this will tell you when it was released also. Let's see when it was released. Cancel for now. This is released, okay, planned release. You can see 3.14 is planned to be released in 10th of Jan. Current version is this, released in July. Or I don't think so. Okay, whatever date format they are following. This is you can see bug fix, bug fix. That is the problem that we have. Okay, with open source programming language, right? But there are numerous advantages, right? There are numerous advantages. It's very accessible, easy to use, and uh, if you make script once, you can use it forever. Okay, it's not like you have to pay annual charges to STAD or ETABS like that. You make it as you want and use whenever you want, wherever you want. Okay, that is what I wanted to tell. If I could, I can show you the course content also. Have you seen the course content, or should I show? Can you see the syllabus or the course content?
Yes,
Yes.
sir. It's
Yeah,
well.
yeah. So this is how we are going to proceed. We'll have first in every case we are going to have hand written derivations. Okay, we'll derive it together. I'll be writing along with you because there are so many mathematical steps which we miss during academics. Or directly, if you take A.K. Chopra's book also, there are some steps that they understand that okay, you must be knowing this. But see, you have done your 10th, 12th long back, and when you start understanding this higher level of mathematics, you're not prepared. Okay, so there are some mathematical concepts that we need. So every derivation we are going to do, a detailed derivation we are going to do. Then we are doing a hand calculation for numericals, and those will be coding. See, the drawback of hand calculation is what you can get response at certain time interval t. Let's say what is the response at 0.4 seconds, or what is the response of a building at time t equal to 3 seconds. But I can use coding like a Python program wherein I can get the history of response. That's what is the graph that you have seen. Okay. Uh, uh, so that graph will make you understand the response of the system throughout the time interval for which the vibration is existing. Of course, this is a building block, right? We have free vibration, we have forced vibration, we have undamped, damped, then in damped again we have three cases. And we are also going to take forced vibration, and then I think we are going to take Duhamel's integral also, right? So all these things we are going to cover, and I'll make sure that if you go through this course, you'll have very sound understanding of structural dynamics. Uh, and you'll be able to use any software of your choice with very good theoretical background as well as the practical implications of the same. Like if you are like I was stuck with this problem of separating my two modes by 10%. It was very close to each other. So 4% is nothing. 1% to 4% I came. Then from 4 I directly jumped to 12. So I satisfied the codal requirement. So that is how you need to understand and to practice as well as to do research, because earthquake engineering is really the field wherein a lot of innovative ideas are coming, a lot of research is going on, and computational analysis is absolutely necessary, right? So having a tool that you can use without much licensing fees, much I would say it is zero. You are using it for free, right? So, and not just structural dynamics, you can do almost everything in this. You can do your reinforced concrete design, you can do your steel design, all customized. Like you have Excel sheets, you can do prepare Python programs, and you can use it day to day, like I use. Okay, so I believe this introduction is good enough. You can communicate with your feedbacks. Now I'll just go back. Okay, just a second. Yeah. So now we are open for questions. If you have any, can you ask? Okay.
Sir, can I, hello, sir.
Yeah. Yeah.
Sir, can I share the course content details more?
Yeah, please,
with
please, please.
students?
Yeah, please.
Okay, so I am sharing the screen, sir.
Yes, I'll stop sharing. Yes.
Hello, students. Is my screen is visible to you all?
Yes, it's visible.
Okay, thank you. Actually, we have an update that we are going to start a new course on a visual introduction to structural dynamics with Python. It is a live course. It is a live course. It is mostly of 40 hours of duration. This course is covered by Shivaji Madhukar sir. He is the who is the instructor of today's webinar. We have a own, if you want to enroll in this course, we have an own app, Bhavanam C2C. It was available in Play Store. You can go through it, or else we will share a course link in our WhatsApp group also. You can go through it also. Once we have gone through the Bhavanam C2C app, search for visual introduction to structural dynamics with Python course. In that, you find an interface like this. In then, actual the course price we offered for students is 12,000 actually, but for students we are offering for 6,000. But we have a special offer who have enrolled for this webinar and attended to today's webinar. The offer is we are going to offer this course complete course with 3 years validity, and that to live classes for 3,000 only. If you come to Bhavanam C2C app and search for visual introduction to structural dynamics with Python course, in that you find the interface like this, and then you apply the coupon code structure STRU01 coupon code. You will get the course price of just 3,990 rupees only. This offer is for validity only for 24 hours for those who have enrolled in this webinar only. So if you want more details, you can contact our Bhavanam C2C team. We are available in that group also. Our numbers are available in that group. So you can go through and search for it. If you require any information regarding this, you can contact us. I hope you guys understand. Sir, you can take the doubt section, sir, from the students.
Okay, thank you. Okay, if anyone has any questions, I am open to answer. Any questions you can ask, no problem.
Hello.
Yeah.
Sir, myself Akhil, sir.
Yes.
Sir, so I'm a master student in earthquake engineering.
Okay. Which
Uh,
institute?
Sir, UVC Bangalore.
Okay.
Sir, regarding this perform-based design, sir. Hello.
Yes. What is your question? Yes, tell me.
Sir, regarding this perform-based design, like how is it different from normal design, sir? Like,
In performance-based design, we achieve the performance. We give stated goals. Let's say I am doing investment. Let's say a hypothetical case. I have 100 crores and I want to build a building. So I'll go to a structural engineer and I'll say build a building. Now he must tell me that if magnitude 6 earthquake comes, my building is not going to have any damage for which I need to do any repairs. Okay. If magnitude 6.5 earthquake comes, the structure will have certain amount of damage for which I need to pay, and that is a repairable damage. The building is not going to go beyond repair. That means it is you can easily repair and reuse the building. If magnitude 7 earthquake comes, my building is going to go beyond repairs and it is near demolition stage, right? So that much information we can give by doing a complicated structural analysis, which is nonlinear, and we get what we can say our building's performance. Okay, at this earthquake, at this magnitude, what is the performance? Are we in the there are levels? If you have studied this, immediate occupancy, collapse prevention, life safety, right? All these levels are based on certain magnitudes of strains in the structural element. The initial video I showed you from Perform 3D, there was color coding, if you recall, the red color, yellow color, the green color. This is the occupancy levels. Okay, that is how you achieve performance, and then you convey that, okay, this is how we are achieving, this is the performance of our building.
okay, sir. Sir, one more thing, sir.
Yes.
Like this one, you told regarding the Perform 3D software, no,
Yes.
sir.
Yes.
Yeah. How is it different from normal ETAPS or SAP 2000, sir?
See, this is quite different because you have to give nonlinear parameters. Structures, okay, ETABS also had certain degree of nonlinearity which you can introduce, but Perform 3D you can do a completely fiber-based nonlinear modeling. So here we are doing elastic elements, 1D elastic element, 2D elastic element, right? In Perform 3D, we'll have a fiber-based nonlinear analysis. So that particular software is basically used for nonlinear analysis. And here
Yes.
you have to create your own components. You have to assemble like a beam or a column is divided in different sections, different fibers. And then
Yes, sir.
each fiber is assigned a nonlinear stress strain behavior and it is analyzed.
Okay. Sir, is there any like there's a software known as Sesmo Signal, sir?
Yeah, Seismostruct is also there. Yes.
Yeah, Sesmo.
Mhm.
Sir, like actually, like one of my professor told to go through that.
Yeah, that is a very good software you can study.
Yes, sir. So, sir, related to that, if you can give some knowledge. Great.
Seismostruct is again a nonlinear analysis software, which is similar to, but it's much okay. Perform 3D is the highest one. Then the next best you have is a Seismostruct. Again, you use that software. It's very good software. You can use now. There are guidelines
Okay, sir.
available. You can do
Okay,
it
sir.
through their website also.
Okay, sir. Thank you.
Yeah, and one more thing, there is a question. Everybody is new to programming language. See, I am also a civil engineer. I am also a structural engineer. I have also started learning this. I started with MATLAB. It has a very steep learning curve. So I left MATLAB and I'm coming to Python. And believe me, by the end of course, you will write your own script and you will be able to, optimize your workflow, right? uh, we are going to start from scratch. That's why you see first 1, 2, 3 sections, we are focusing on building our understanding how to program. Okay. So don't worry, we are starting from scratch. Okay.
Sure, sir.
Okay. Anything else?
So I have one question.
Yes, yes. Tell
Yes,
me.
myself, I have completed my master's in structure in 2016.
Okay.
Now I'm pursuing my PhD.
Okay.
Now I'm also working as assistant professor in engineering college.
Okay.
So learning this course, how it will help me uh, in academics, or suppose I want to work in industry. What is the output of this course? I'm not getting still.
See, if you are researcher, first of all your graphs that you can do is as customizable with highest resolution you can do through Python. You plot your graphs not in Excel, plot it in Python. That is first thing as a researcher because you are doing your PhD. Second, you are having you are teaching also, right? So if you are teaching, let's say structural analysis, or you are teaching um, any design subject, you have to do the coding once and you can use your Jupyter notebook. Your notebook will be ready, which you can give directly to the students. Once you have, if you have done this, your question banks are ready. You can solve 1,000 problems within 2, 3 minutes, right? So, and if you are joining your consultancy or any office, if you are joining, you have ready-made available sheets with you from where you don't need to invest a lot of time on designing through software. You can, because you don't know what is happening. Okay. Unless and until, okay, RCDC has better functionality to show, or even ETABS does, but unless and until you do the design, you are not confident because it is the question of lives of the people. So we want to have our design uh, spreadsheets or our programs which takes the analysis output and we design. Okay, because we have more control, right? So all the three ways your teaching learning experience will enrich you. You can teach in a better way. Students can learn in a better way. They can interact, and all across domains you will have multiple benefits. Not just in academics, in your personal life also you can use Python to do, let's say, personalized reports you want to have. You want to have a technical document, and you want to print with high resolution images. Okay, that you can do through Python. So there are a number of advantages. Simple programming will help you in creating no, avoiding repetitive tasks. You don't need to, your question bank, question paper solution also you can print, right? So now even if I teach, let's say if I'm teaching the design of steel structures, I have my scripts written already. Okay, I can if I ask the question, let's say the exam ends, if the exam ends, then and there itself I can give my solution, very well documented solution. Okay.
Okay, thank you, sir. One more question, sir.
Yes.
Is there any chance to consider this as a new career option and
Yes, definitely. See, who develops the software? We only develop, right? The computer engineer is not going to develop structural engineering software, right? So you can work with Midas, you can work with Bentley, you can work with CSI. If the opportunity comes, you are able to develop a software. Okay, you are able to write your own programs. You are able to make, see, Python can do a exe file. Okay, like I have my exe file wherein I can design two-way slabs, right? With all the end condition mentioned in NXRD, right? Nobody needs to have Python. Simply install the exe file. Within few seconds, you will get a text output also, and you will get uh, your. Of course, Python is integrated with AutoCAD also. That is also a possibility, right? So much of customization is possible.
okay, so we can consider this as a new career option also.
Yes, absolutely. A developer option, a structural engineer doing structural engineering programming is absolutely essential. It is the added advantage, isn't it? Computer engineer is not going to understand what is a bending moment, what is the shear force, isn't it?
Okay. Thank you. And about what you said that it can give us CAD images or CAD drawing also.
Yes, you can see there earlier people used to use Atolis to customize CAD. Even Visual Basic they used to use. But AutoCAD is like all the softwares, everybody is giving Python interface. So you can write in Python and you can get it in CAD. Like in my office, what we do is we have a standardized layer created in Python file, and I get those same layers in my CAD. So I don't need to do all this time, new layer, new layer, new layer. I'll write a script and I'll run this. CAD will have the same layers.
Okay, so that will be also covered in the during this session.
No, this course is specifically related to dynamics. Okay, but we'll have more courses on Python integration with, let's say, I take stat output and I do beam column capacity check. Let's say there's a new ductile design of steel structure is there, right? All this we are, see, unless and until we start somewhere, all this Python customization with other softwares like we have APIs, we are going to cover as we progress.
Okay. But with the part is only limited to single degree. Why is it so, sir?
Unless and until we understand single degree of freedom system, we won't be able to understand multi-degree of freedom system. And single degree of freedom system has a lot of variations. So fundamental understanding, this is the first course that we are starting, right? Once we finish single degree of freedom system, then we'll go for multi-degree of freedom system. Then modal analysis, then modal participation, then response spectrum. All these things will be easy to understand. That's why to start with, you must understand single degree of freedom system. Even your nonlinear pushover analysis or all this that you do, it's a manifestation of single degree of freedom system only, isn't it?
Okay, sir. And actually, I have already forgotten all this dynamics. So, is it required to go through all those concepts first before joining the course?
No, nothing. You don't need to do anything. We are starting with the derivation first. Theoretical background, we are going to derive it mathematically, or we are going to use pen and paper to derive, not just mathematical understanding. We'll have a visual understanding by coding the same response. We'll solve numerical by hand calculation, and we'll do plotting in the Python also. So we are going to cover everything. Even if you have forgotten most of your dynamics, it's absolutely okay, right? We are not going to, jumping anywhere. We are starting from the scratch.
Okay, means this is the only start of the course using Python. You have much more to be covered later, I think.
Yes. We are planning for, see, once we finish with this, we'll go with MDOF, and then we'll go with integration with other softwares.
So basically, your expertise is in this Python, and you have made much more things easier using Python, I think.
Yes.
Okay, so you will help us to do the same.
Yes, definitely.
Okay, thank you, sir. No more questions. Thank you, sir. Satisfied, sir.
Okay.
If course starts, what will be the time we can have the course? At what time?
Yes, we will discuss that. Okay, we'll be informing you. Okay.
Okay.
Any other question?
Hi, sir.
Yes. Hello.
Sir, I am from BTech third year, sir. I am.
Okay.
This is very huge task, I think, for me.
No. Don't worry. You are in first semester of third year?
No, sir. Yes, sir. Yes, sir.
Okay. So you have, is this course there in your curriculum right now?
RCC is there. RCC there, sir. Structural engineering
Yeah. So
and
see,
structural analysis also.
yes. See, there are two advantages for you to learn. See, you will get advanced understanding of structural design first, and
Sir.
design of RCC structure that you are doing.
Yes, sir.
It's a stepwise process. Why it is easy for structural engineers to use Python? It is because we already have algorithms. See, stepwise process that we have, it's an algorithm for us, isn't it? So
Yes, sir.
once you start learning a language, you put that algorithm to test, and you will understand much beyond what the classroom teaching will give, right? So even if you enroll, you are going to get a lot of benefit out of this.
Yes, sir. Okay, sir.
Okay. Anybody else? Okay, I think there are no more questions now.
What prerequisite will require, or what things to be we should have? At least we should have laptop, I think.
Yeah, you should have laptop because see, you can code on mobile or tablet also, but a basic laptop will do. Laptop or desktop will do. It doesn't need to have any higher configuration. Any regular laptop will do.
Okay. And material, what else material we'll get it from you?
You will get the Python programs that will do. Anyway, you are doing with me, so that's not a big problem. Derivations we are doing, that PDFs you will get.
Okay.
Yes. Okay, I believe there are no more questions. Is it?
Only the question is of time, sir, because we
Yeah,
are
that we are working on. We'll let you know. Okay.
when it will start. That is also the point.
Yes. That is a administrative lookout. We'll see that and we'll let you know.
Thanks.
Okay, so should we end this webinar?
Yes, sir.
Okay. Then thank you very much for all having a very good interaction with you all. I hope to see you in the course and enjoy the programming journey. Again, as I told, it's just the start. We are going to go a long way. So it's not just one course. There are multiple courses in pipeline. So I hope to interact with you all soon. Wishing you a very good evening. Take care.
Thank you, sir.
Yeah,
Good day.
thank you. Thank you very much.
Can I end the section?
Yes, please. Yes.
Thank you, sir.
Yes. Thank you. Thank you.